Welcome to Zoom in Data. In this session, we will discuss Databricks Structured Streaming, which is a powerful stream processing engine built on Apache Spark and deeply integrated with Databricks. Structured streaming is widely used to process real-time and near real-time data such as logs, events, IoT data, and user activity streams. This topic is extremely important for interviews because it tests a candidate's understanding of real-time data processing, fault tolerance, and scalable pipeline design. A strong grasp of structured streaming helps data engineers build reliable, low-latency data solutions in production. Key points covered in this subtopic: concept and architecture of structured streaming, streaming data sources, sinks, and processing model, fault tolerance, checkpoints, and triggers, interview-focused explanations and real-world use cases. Subscribe to Zoom in Data to continue structured learning of Databricks concepts. What is structured streaming in Databricks? Structured streaming is a scalable and fault-tolerant stream processing engine built on Apache Spark. It allows developers to process streaming data using the same APIs as batch processing. Data is processed incrementally as it arrives in small chunks. This unified approach simplifies real-time data pipeline development. Why is structured streaming important in Databricks? Structured streaming enables real-time data processing at scale. It integrates seamlessly with Databricks and Delta tables. Engineers can reuse batch logic for streaming use cases. This reduces development time and complexity. How does structured streaming differ from traditional streaming systems? Traditional streaming systems often require separate APIs and logic. Structured streaming uses a declarative, SQL-like programming model. Developers focus on what to compute instead of how. This makes streaming pipelines easier to understand and maintain. What is the processing model of structured streaming? Structured streaming uses a micro-batch processing model by default. Incoming data is processed in small, continuous batches. Each batch is treated like a small Spark job. This model provides strong fault tolerance and scalability. What is a streaming source in structured streaming? A streaming source is where streaming data originates. Examples include Kafka, cloud storage, and autoloader. The source continuously provides new data to the pipeline. Structured streaming reads data incrementally from the source. What are common streaming sources supported in Databricks? Databricks supports Kafka, autoloader, event hubs, and cloud storage. These sources handle high volume and continuous data streams. Integration with cloud services is seamless. This supports enterprise-grade streaming solutions. What is a streaming sink in structured streaming? A streaming sink is the destination where processed data is written. Common sinks include Delta tables, cloud storage, and Kafka. Data is written incrementally as it is processed. Sinks define how and where streaming results are stored. How does structured streaming ensure fault tolerance? Structured streaming uses checkpoints to track progress. State information is stored reliably in checkpoint locations. In case of failure, processing resumes from the last checkpoint. This ensures exactly once or at least once processing guarantees. What is checkpointing in structured streaming? Checkpointing stores metadata about processed data. It tracks offsets, state, and progress of the stream. Checkpoints are required for fault tolerance. They enable safe recovery from failures. What is the role of triggers in structured streaming? Triggers control how often data is processed. They define the frequency of micro-batch execution. Examples include processing time and once triggers. Triggers help balance latency and resource usage. What is a micro-batch in structured streaming? A micro-batch is a small batch of streaming data. Data arriving within a trigger interval is grouped together. Each micro-batch is processed like a Spark job. This approach simplifies streaming execution. What is continuous processing mode? Continuous processing is an alternative low-latency mode. Data is processed continuously rather than in micro-batches. It offers lower latency but fewer features. It is used only in specific advanced use cases. How does structured streaming handle stateful operations? Stateful operations maintain information across batches. Examples include aggregations and window operations. State is stored and managed internally by Spark. This enables advanced streaming analytics. What are window operations in structured streaming? Window operations group data based on time intervals. They allow aggregations over fixed or sliding time windows. This is useful for time-based analytics. Windows are common in event stream processing. How does structured streaming integrate with Delta tables? Structured streaming can read from and write to Delta tables. Delta provides ACID guarantees for streaming data. Streaming writes are reliable and consistent. This is a core part of the lakehouse architecture. What is exactly once processing in structured streaming? Exactly once processing ensures data is processed only once. Checkpoints and transactional writes enable this guarantee. It prevents duplicate records in output tables. This is critical for financial and analytical data. What are common use cases of structured streaming? Processing real-time logs and application events. Streaming analytics for dashboards and monitoring. Ingesting IoT and sensor data. Powering real-time business insights. How does structured streaming scale with data volume? Structured streaming leverages Spark's distributed architecture. Processing scales horizontally with cluster size. It can handle high-throughput data streams. This makes it suitable for enterprise workloads. What are watermarks in structured streaming? Watermarks handle late-arriving data. They define how long the system waits for late events. This prevents unbounded state growth. Watermarks improve performance and correctness. What are common interview questions on structured streaming? Interviewers ask about micro-batches and triggers. Fault tolerance and checkpointing are key topics. Windowing and stateful processing are commonly tested. Real-world streaming examples strengthen answers. What are best practices for structured streaming? Always configure checkpoints properly. Use Delta tables for reliable syncs. Monitor streaming jobs regularly. Tune triggers based on latency requirements. How does structured streaming support near real-time analytics? Data is processed as soon as it arrives. Micro-batches provide low-latency execution. Results are continuously updated. This enables real-time dashboards and alerts. How is structured streaming used in enterprise projects? Enterprises use it for real-time data pipelines. It simplifies complex streaming architectures. Integration with Databricks reduces operational effort. It improves time to insight for business users. What limitations should be considered in structured streaming? Long-running streams require careful monitoring. State management can consume memory. Proper tuning is needed for performance. Understanding streaming semantics is important. Why is structured streaming important for Databricks interviews? It demonstrates real-time data processing expertise. Interviewers value practical streaming knowledge. It shows understanding of scalable architectures. Mastery improves confidence in interviews. Thank you for watching Zoom in Data. If you found this video helpful, like, share, subscribe. More Databricks interview and tutorial videos coming soon. Stay connected and keep learning with Zoom in Data.